Math 148, 11.1 Derivatives of Logarithmic Functions, Part 2. So, change a base formula. The log base a of x equals the natural log of x over the natural log of a. This is done so that we can take the derivative of the numerator here because we don't have a formula for this. So what we're going to do is we have an example here where we have log base 3. I can't take the derivative because it's not natural log. So the first thing I'll do is use change of base to convert it to natural log. So we have y equals the natural log of x to the fourth plus 2x cubed minus 8x plus 1 over the natural log of 3. So you could think of this as 1 over the natural log of 3 times the natural log of x to the fourth plus 2x cubed minus 8x plus 1. So y prime will equal 1 over the natural log of 3, because that's a constant, it doesn't ever change. You always get the same value. Now I'm going to take the derivative of that, which is 1 over x to the fourth plus 2x cubed minus 8x plus 1. And then the chain rule comes in and says that's 4x cubed plus 6x squared minus 8. So writing that out, we would have 4x cubed plus 6x squared minus 8 all over natural log of 3 times x to the fourth plus 2x cubed minus 8x plus 1. I'd like you to try that one. That one there. Okay, so for this one, we're going to use the log properties first. So this is going to be the log of x to the fourth plus the log of 2x cubed minus 1 cubed. So this is going to become 4 log of x plus 3 log of 2x cubed minus 1, which is 4 natural log of x over the natural log of 10 plus 3 natural log of 2x cubed minus 1 over the natural log of 10. So this right here and this right here is a constant. So they'll be able to come out front. So f prime of x equals 4 natural log of 10. The derivative of log of x is 1 over x plus 3 natural log of 10. And then we'd have 1 over 2x cubed minus 1. Chain rule is 6x squared. So this is going to be 4 over natural log of 10x plus, well, 3 times 6 is 18x squared. Natural log of 10 times 2x cubed minus 1. So go ahead and take the derivative of this. So we need to take the natural log of x squared plus 1 over the natural log of 4. So f prime of x is 1 over the natural log of 4 times the derivative of the natural log of x squared plus 1, so that's 1 over x squared plus 1. Chain rule says 2x. So we'd end up having 2x over the natural log of 4 x squared plus 1. Suppose that the supply of x units of a product, price p dollars, is given by p equals 15 plus 75 natural log of 2x plus 4. Find the rate of change of supply price with respect to the number of units supplied. So in other words, what is p prime? So I need to take the derivative of this. So p prime, so 15, the derivative of 15 is 0. So that gets me 75, 1 over 2x plus 4, chain rule times 2. And I can simplify that by, I can actually reduce the denominator. So that would be 75 over x plus 2. So now we have to add in 23. So p prime of 23 is 75 over 23 plus 2. 75 over 25, which is $3. So approximate the price increase associated with the number of units supplied changing from 23 to 24. The price will increase approximately by, well, that's what it says. If my derivative at 23 is $3, it'll approximately change $3 the next time you do a whole unit increase. Okay, so find the derivative of these. So ds over dq equals 1 over 3q squared over 8 plus 2 times the derivative, that would be 6q over 8. Okay, so I am going to take this 8 and distribute it to here because it's a denominator. So this is going to become 6q, and then I will have 3q squared over 8 times 8 plus 2 times 8, which is 6q over 3q squared plus 16. Okay, let's take a look at this next one, example 7. So I now have a logarithm here, and then I've got a quotient. So I've got to use the quotient rule, but within the quotient rule, I'm going to be taking derivatives of the natural log. So let's go through this. Y prime equals x cubed squared x cubed. And then the derivative of the numerator is 1 over x minus the numerator that would be 5 plus natural log of x times the derivative of the denominator, which is 3x squared. So if I take and simplify this a little bit, I have x squared minus 5 plus natural log of x times 3x squared over x to the 6th, which is x squared 1 minus 5 plus natural log of x times 3. So I can now get rid of this, and this becomes a 4. So this is 1 minus 15 minus 3 natural log of x over x to the 4th. And this would be negative 14 minus 3 natural log of x over x to the 4th. And I'm going to have y prime for that.